Hello and welcome. In this presentation, I'll first talk about electrical engineering, provide you some insights into it as a discipline, and go over 3 job titles in this major. So first, electrical engineering. It is easy to see around us the presence of electronic devices. So we who study or work at FDU interact with electrical things all the time, regardless of whether we are on campus or studying or working from home. Right, so let's visit the past for a few moments. Electrical engineering, where it began. The term electricity might take us all the way back to 1600, when William Gilbert, a scientist, used the word. It's considered the first use of the term electricity. And then, in the 19th century, it witnessed more research and study in electricity. One invention that is considered the first example of electrical engineering is the electric telegraph. The electric telegraph at the time was a remarkable invention at the time. So from the world where written letters were the only means to communicate over distance, a new reality emerged where it would take minutes to less than an hour for a message to travel across continents over land and sea. In 1882, at Darmstadt University of Technology, Erasmus Kittler founded the Department of Electrical Engineering and established this discipline in the engineering world. Later, more universities and institutions adopted this major. As we can see nowadays, electrical engineering is a program that is offered by many schools and institutions. Right, so electrical engineering, where we are now. Electrical engineering is a broad field, and there are 8 major areas. Computers, we interact with computers all the time, and they are what we use to work and study today. Communications, we think of cell phones, cellular networks, global positioning system or GPS, wireless communication among humans and devices. Circuits and solid-state devices, so we can think of motherboard, CPU, chips, whose sizes are very small and compact, yet are very powerful. Control, for example, digital controls enable safer and more efficient operations, as electronic systems are better than humans when it comes to reliability, efficiency, precision, and accuracy. Instrumentation, information may be transmitted and stored via different media. For example, information can come from the satellites outside of this Earth to computers. Signal processing, we can think of electric signals can come from a lot of sources. However, not all of them may be meaningful and usable, and often require further filtering, amplification, and modification before they become usable. Bioengineering, techniques like MRI and CT scans in hospitals, devices like pacemakers and cardiac monitors that are used in biomedical environments. Power, we can think of generation and transmission and distribution electric power in various forms like solar, water, wind, heat, or wave. Right, so let's talk about 3 example job titles under electrical engineer. First, electrical design engineer. So as we know from class 3, design engineers use modern computer design tools and are often supported by technicians trained in computer drafting software. They verify that the parts they are responsible for meet the reliability and safety standards established for the product. They involve manufacturing engineers in the design process, and they redesign existing products that are considered faulty. So, an electrical design engineer is a professional who develops electrical systems, such as alarms and lighting. They use vast knowledge of the principles of physics and material sciences to help create solutions for new electrical systems and provide maintenance or installation services to current electrical systems. Electrical design engineers require knowledge of electrical components, electrical systems, and the principles of engineering to perform their roles. Next, let's talk about electrical research engineer. As we know from class 3 as well, research engineers conduct investigations to extend knowledge. They might be involved in the design and implementation of experience and the interpretation of the results. They might conduct research using computers. They use developed computational techniques to solve complex problems without having to conduct costly and time-consuming experiments. Also, they may as well develop those techniques. Right, so electrical research engineers, they primarily conduct research, aiding the design and development of new and innovative electrical products or systems. They evaluate existing systems to provide improvements. Electrical research engineers must have analytical, math, research, and communication skills. And lastly, electrical systems engineer. As we know from class 3, system engineers work with the overall design, development, manufacture, and operation of a complete system or product. They're responsible for ensuring that the components interface properly and work as a complete unit. They are responsible for identifying the overall design requirements. So electrical systems engineers provide detailed design engineer for drawings and specifications for electrical design in system lighting, power distribution, grounding, fire alarm, communications, and security system control or signal systems. The skills knowledge required include communication skills, knowledge system schematics, ability to support software development, or automated data gathering. Knowledge of automated test equipment and switching systems, a strong grasp of advanced mathematics, organization and multitasking ability. And these are the references used. Thank you very much for listening.